So I hope you are doing fine and all the problems were solved from the previous lecture. And today we'll be starting with another important concept, which is in section 1.2 of your book, Precalculus. That is functions. That is about functions and all. So let me just call that those pages so we can start. Today I shall be taking functions and properties and okay, I'll be doing and covering functions and their properties till domain and range. Continuity of the functions, I'll take it in the next lecture. So this is all which we are having. So I hope we are all clear with the things which we had done in the previous thing. So let's start. Now you already have the idea of what functions are. We have already talked about that functions are something that is causing an output to happen. Like my function is to teach you. So what I'm actually doing, I am using my knowledge which is feeded into me in order to give an output to you. So that is my function. Your function would be that you would be using this knowledge to increase your skills and then get good grades in the exam as the output. That is your function. And moreover, your function is to understand all the concepts which are being taught as the priority. Once you are done with the concepts, you're done with your functions. So let's start. See, the mathematical definition of function. It is very important to know what exactly is the mathematical definition of the functions. So let me just lock all those things so that they're not running away and I'm scrolling them. Now you need to remember this. I advise you that you just write them twice or thrice so that you are actually knowing what are the things which are important. So it says a function from a set D. Now we are having two sets, set D and set R. I'll explain you. It's first time reading what this is given here. A function from a set D to set R is a rule. A function from set D to set R is a rule. Now, what exactly is a function? It is a rule that assigns to every element in D. It is being assigned to every element in D to a unique element in R. Now, one thing to be noted is that a very important word has just come in our line, that is this unique element in R. So, a function from set D to set R. Let's take the example here only. This is some set D and this is some set R. So, a function is something that is actually mapping all my elements from D to some unique element in R. The word unique is of immense importance and must be taken care of whenever solving questions from these functions. So set D of all input values is the domain and set R of all output values is the range of the function. So let's come here. This is exactly what we were trying to talk about. So what is exactly a function? This is my set D, this one. This X is my set D and this Y is my set R. Now, if you note, you'll find out that I am having some elements which is called as x2, x1, x3, and x4 in my set D. And these all elements are actually mapping to some unique elements in my set or set Y or set R as per the definition. Let's take a common thing only which was told in the definition that this is set D and this is set R. It can be anything, but just for the sake of explanation, I'm just putting it to be what exactly it was told. Okay. So this has been told to us. Now you see one thing that every element from my set D, this is x2, this is x1, this is x3, x4, x2 is mapping to y2, x1 is mapping to y1, x3 is mapping to y3, and x4 is mapping to y4. So every element is mapping to a unique element in my set R. So my x1, x2, x3, and x4 are actually my domain because they are giving me some output which I call as range, which is y1, y2, and y3. So if I am being asked that what is the domain of this function, that is x1, x2, x3, and x4. What is the range? Range are all the output values that are y1, y2, and y3. Now, what is not a function? I told you that one word is of immense importance, and that was unique element in R, mapping to a unique element in R. Now, know about one thing that a single value of domain can never give you two answers. Like if I'm writing on my laptop, I'm giving inputs as typing those letters present on my keypad. So the output should be shown on the screen, whatever I am typing. It cannot be that I am typing and it is writing and it is also speaking whatever I am writing and it is also doing something else. So from a one input, I should be getting a unique output. It shouldn't be the case that I'm getting three, four outputs from a single input. Understood? So that is why if you see x2 here, it is mapping to y2. This is unique. My x3, it is mapping to y4. This is unique. X3, it is mapping to Y3. It is unique. But you see, one input is giving two outputs. That is not possible. If I'm typing on my keyboard, that means I'm writing something on that. So it has to generate only one output. That is to show me what I have written on my keypad, not to speak it out what I have written. A better example would be that if I am going to do some bicep curls, that input should lead to only single output, that is to increase the size of my biceps, not of my legs. So one input has to deal with always one output. So if you see this x1, this was single input and this is being mapped to two different outputs, y1 and y3, which is actually not agreeing to this definition that is mapping to unique elements now. So I hope you understood that is why they have written not a function. So it shows that since the rule does not assign the element x1 to a unique element of y, unique element is a priority. Now let's come to this point. They are saying that how we are actually displaying. That is y equals to fx form. This form you will be coming across many times in physics also. So y equals to fx. What actually this thing is telling you about? It says the value of y which you are getting when you are putting value of x in this function. That means the value of f at x. This is actually the thing. Or you can say y equals f of x. This thing is actually pronounced. So it means if, for example, I'm putting my x equals to 2, I would be getting if my function is x square. If my function is x square equals to y, if I put fx equals to 2, so y would be 4. That is x squared. So this is exactly a simple notation which you should know about. And there are two different things which you need to talk about. That is x is the independent variable and y is the dependent variable. So let me just talk about that. What are independent and dependent variable? Independent means the value is not depending on any other variable. if you see x is independent, you can put any value of x into this function, but your y is always dependent on the value of x which you are putting. For example, see here. Here, x is the independent variable. That means I can put any value into my x. I can give any positive, negative, zero, any value to my infinite values to my x, and still it will generate an output. But my y, which is a dependent variable, it is depending upon this thing, the value of x. So y becomes the dependent variable because it is depending upon x, and my x is the independent variable. So this is another simple thing. So I hope these concepts are clear. Next is a function can also be viewed as a mapping. I've already talked about mapping. Mappings means mapping of elements of domain onto elements of the range. This definition I had already given while explaining that it is a mapping of elements of the domain into the elements of the range. So I hope this thing is also clear. So there's a bit of history which you can read about, and that is about Euler's notation. Okay, now let's move forward. Now they are talking about x coordinates and y coordinates. Okay, let's solve them graphically, then only we can find out what exactly we need to check. The first is an example. Defining a function. Now, we have already talked about this example just moments ago. So y equals to x squared. This question is given to you and defined as y is a function of x, which means you can put any value of x. So yes, y is a function of x. They're asking you, is this a function? So yes, it is a function. In fact, we can write the formula in function that fx equals to x squared. You know that y equals to fx and y is already equals to x squared. So y equals to fx equals to x squared. It is simple notation. For every value of x, you are getting some value of y. Okay, my mouse is making noises. Moving forward, when number x is substituted in the function, the square of x will be the output. So there should be no ambiguity actually in this one. Now, graph of this function, seeing the function graphically. Okay, now another method is to find whether the function, whether the thing which you are seeing in the graph is actually a function or not. Now, there is something which is called as a vertical line test. Now, by the name only you're understanding, vertical line test means something to do with vertical line, which means, see, if you want to identify a function instantly, just do one thing is to draw vertical lines all across the graph and see that your vertical line should be cut by the graph at only one point. Now, if I draw my vertical line here, it is only cutting at this point. Again, let me draw some more vertical lines so that it is being clear what I'm just talking about. Okay, I've drawn four vertical lines, not taking point. Now, see, my graph is coming like this. It is cutting the vertical line at this point. Now, here it is cutting at this point. Here it is cutting at this point, and here it is cutting at this point. So this is a function. Why? Because my vertical line test is true. That means my graph should cut the vertical line at only one point. So this is true. Now, let me just take these things. One, two, three, one. Why this is not showing me one? Okay, they are wanting me to do more hard work. So we shall do. Why it is behaving like this? Okay, I should so this one, then another two, then another three. See, vertical line means a vertical line. So just draw vertical lines and see. You can even see without drawing. I'm just making it so that you, because it's the first time for you. So this is cutting my graph at one point. This is cutting my graph at one point. This is cutting at one point. This is cutting at one point. So this is also passing vertical line. This means this is also function. So A and B are functions. Let's check for C. If I'm drawing my vertical line at any point here, okay, then at next point here, then at next point here, okay, this is tilted. It has to be vertical line and everything has to be vertical line. So this is also done. So moving forward, you see this is touching the graph at this point. So this is true. Now here, this vertical line is cutting the graph at 1 point, 2 points, and the third point. Again, here also it is cutting at 1 point, 2 point, and 3 point. So my vertical line test is actually failing for this one. because as per the rules which I've already told you, vertical line should intersect the graph only at a single point. But and this should be true for the whole graph. This doesn't mean that this line is touching at only one point, so vertical line test is passed. No, all the vertical lines should be passing through only or intersecting through only one single point. And how you can just imagine when I put the value of x, because this is the x-axis and this is my y-axis, whenever I'm putting the value of x is equals to 0, I'm getting my y equals to 0, y equals to 2, and y equals to minus 2. That means for my x equals to 0, my y is 0, 2, and minus 2. That means for one input, I'm getting three outputs. And we already learned from this where it has gone, why it behaves like this. We have already learned from this graph that single input should not give two outputs. So my x, when it is 0, it is giving me 0, 2, and minus 2. It is mapping to three elements, and my mapping should have been unique. So this is third one is not actually a function. So the vertical line test, what it is? So graph set of points in the xy plane defines y as a function of x if and only if no vertical line intersects the graph at more than one point. Understood? So you need to just check that your vertical line is actually passing from one point. And this here they are showing which is not a function. You see the graph in C is not the graph. This is what I have explained to you. Moving forward is a topic about domain and range. We are already talking about this. So domain is what? Domain is the value which you can already put, which you can put in a function. So let's solve example. Understand by solving the example, there are two different things, relevant domains and implied domains. So just we shall be doing the examples to know about all that. Now you see one thing. First, fx equals to under root of x plus 3. Now I am drawing a number line, like a number line. It should be just a second. This is my number line, which looks like a number line. Fine. Now, coming on to the other part, that is, this is my zero marker. Positive numbers to the right, negative numbers to the left. Now it says x plus 3 in under root. Now you know that an under root can only take positive real values, right? It can only take inside it is the positive values. And it can also take 0, including the 0. So what all I can actually put inside this x so that the least possible value which I'm getting inside that root is 0, because square cannot take a negative number. So if my x, now let me just tell you, this is 1, this is 2, this is 3. Ignore my difference in these bars. This is minus 1, this is minus 2, this is minus 3, this is minus 4. Also ignore my writing, bad writing. This is a trademark stuff until I get that writing bad. So you see, if I'm putting 0 into this function, I'm getting root 3. Good, it can give me the value. If I'm putting minus 1, I'm getting a 2. Good, it is a positive value. If I'm putting minus 3, I'm getting 0. If I put minus 4, I'm getting minus 1. So root of minus 1 is a complex number. And complex number means those dead numbers which we cannot see, they are coming from some imaginary land. So root can only take positive values. So it has to be minus 3. So all the values which I can take are to be greater than minus 3. That means I hope you have understood this thing. So I'm just removing this off and getting this also off so that I can tell you. So what actually has to be my domain? Domain means all the values which I can put in. So what all values I can put it? I can put the values of x which are greater than equals to minus 3. Understood? I can put all those values which are actually greater than equals to minus 3. And that has to be my answer. Why? Another way of defining this thing is to be in terms of set notations, right? How is to be the set notation formed? See, my x has to be greater than equals to minus of 3. This can be given in terms of set notation, which says my x will belong to uh, what? This this means including minus 3, comma, infinity. And infinity, we are always using this type of bracket because infinity can never be included as the answer. Now, one more thing, x belongs to is given by this sign, this. So you can write x belongs to this interval. So x belongs to this interval, this is your domain, or you can simply write x is greater than equals to minus 3. This is your domain. So this is the answer. Let's check what they are actually giving. So say the expression under radical may not be negative. Square root cannot be negative. So we set x plus 3 is greater than equals to 0. To solve it, we find out that x is greater than equals to minus 3. And that interval is this, which we have already discussed about. So what you needed to do was you need to just put the thing which is inside the square root greater than equals to 0. And you will find out the things. No matter what is inside their square root, just put all those equation greater than equals to 0 and solve that equation to find out what is the value which you are getting. So this is done. Now coming to the next example, that is gx, that is root x upon x minus 5. Now one thing to keep in your mind is that anything divided by 0, if I divide a by 0, what answer you're getting is infinity. That is undefined. This thing is undefined by the laws. So you cannot divide anything by 0. You can multiply things by 0 to get a 0, but you cannot divide by 0, otherwise you will be getting a huge infinity. That is not possible by the laws of maths. So that is undefined. So you cannot get a 0 in denominator. So whatever you cannot get, just use contradiction method to find what you are looking. You don't want a 0 in denominator. So just put it unequal to 0. That is x minus 5 unequals to 0. You don't want that thing. So you're just putting it exactly equal to that thing. So you're getting x should be unequals to 5. Okay. And you can also use contradiction, that is x minus 5 equals to 0. So you'll be getting x equals to 5. That means whenever you put the value of 5, you'll be getting a 0. That means you cannot use 5. So this is also true. So one thing we have found out, that is x is unequals to 5. First thing. Now look onto the denominator. Denominator, you're having your x is under the roots. Now, under the root gives me impression. What shall be the first impression? That I need to put whatever that thing is inside greater than equals to 0. So, two things to match. That is, x should be greater than equals to 0. Union x equals to 5. Right? Union means these two concepts you need to take into consideration. So, how I can actually define it on number line? That is the best method of finding out. Just draw the number line, and this is your very big circle. This is not what I am wanting. So I'll delete it. I'll use my pad and writing to tell you that this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and so on, going on to infinity. Now, what all values I can actually use? I'm just drawing it here. Just take me in example, that is, I can use all the values which are greater than 0, except the value for 5. Rest everything I can use. So I'll just try to, if I can just make a line here to let you know that, okay, this is the first thing. And the next thing is this. A number line notation, it is of this type. Fine. That means 5 is not included in this. All the values greater than equals to 0, but not including the value of 5. So let me just clean this all and tell you in short what actually you should be writing here. in your answer because you cannot draw number line. If they're asking you to draw number line, then it is fine. So I said you x is greater than equals to 0. So what you can do, one method is just use this notation a 0 comma infinity. This has to be there. Subtracted by curly braces 5. Now anything you put in these curly braces is subtracted. Subtracted means you're subtracting from that. So from this interval, you're subtracting the value for 5 because you cannot use 5, otherwise you will be getting a 0 in the denominator. So one method is this square brackets. That means you are actually including 0 to infinity, excluding the value of 5. One method is this. This is the simplest method. This is not the simplest method, but you will come across later. And another method to show is that x is greater than equals to 0, but x is not equals to 5. Simple. So, okay, they have shown in this term. This is also the final expression 0 to 5, union 5 to infinity. That means you have excluded the 5. This open bracket means that you are excluding the 5. So we have talked about three different notations by which you can actually know and write the things. Done. The third is as equals to under root of 3 by 4 f square. This is an area of equilateral triangle. So 3 root by 3, 4 s square. So what are the values of s which you can actually put into this domain you are being asked of? So s, because it is a square, the first thing that comes in your mind is it can take all real values. The domain has to be all real values because it is a square. You put negative sign, you're getting a positive answer. You put any thing, you're getting a positive answer. But just imagine that how can a side be of negative length? That is not possible. They're talking this is an area of the equilateral triangle with side of length s. So your side cannot be negative number because negative length doesn't exist. It has to be positive length or zero length. So what all you can use is 0 to infinity. That means only the positive real numbers. Okay, only the positive real values you can use. So this is the domain factor which we have learned about. And support graphically also you can just draw and tell them that why this thing is actually the thing. Now coming on to the range factor, we have talked about domain. Domain is what you can actually put into x to get the value for y. Now here comes how you are actually going to find out the range. Now, range means what are the values of y which you are getting. So just do one thing which I'm telling you. That is, like here it is giving you fx equals to 2 by x. So you know fx is equals to y. So keep it equals to y. You're putting it equals to y. Now rewrite this equation in terms of x. So if you want to write this equation in terms of f, you need to just interchange the places of this and this. That means x is equals to 2 upon y. Understood? This is x equals to 2 upon y. So now my function is just the opposite. What I am doing, I am putting the values of y, which will give me the values of x. That means my function is now f of y is equals to 2 of y. Why? Because I am putting the values for y to get my values of x. I'm doing the opposite thing because we are calculating the range. That is the output. So we'll be doing the opposite thing. So 2 by y. Now know one thing that y, what all values you can put in y. That means y cannot be equals to 0. Y cannot be equals to 0 because denominator would be 0, your answer would be indefinite. That is why infinity. So infinity at 0, that means the graph would tend to infinity. So you cannot put 0 as your answer. So what actually you are deceived? It appears that x equals to 0 is not in the domain. It is not appearing, it is actually is because we have already learned that we cannot put 0 here into this because anything divided by 0 is infinity. Let's see what all example they are actually providing us with. So what are the values which we can actually use in y? The values which we can actually use in y is this minus infinity to 0 union 0 to infinity. So what we did, the first step is to rewrite the equation in terms of x. The moment you rewrite the equation in terms of x, you are getting the main equation in terms of y. Exactly. You're getting the main equation in terms of y. That is what you are needing to calculate because you are wanting the range to be calculated. You're not pertinent to finding the domain of what you can put into x to get the value of y. You are now checking out that I have put these all values of x. What shall be the answer range? What my output shall be coming in what range? So now you know that y cannot be equals to 0. So that is what we have just written. Y cannot be equals to 0. So this was all about today's lecture. That is domain and range. I'll be giving some questions to you about finding the domain and range for those things. And in the next lecture, we shall be discussing upon some questions, some more questions about domain and range concept, because this is an important concept. And we will be dealing with some functions in the next subunit, I guess. So this will clear all the things. The next thing which we'll be dealing with is continuity. So let's meet in the next lecture tomorrow and deal with what exactly continuity is, because continuity is an important fundamental unit of life also, because whenever there is a discontinuity in anything, we don't get the results which we are wanting. So I want you to be continuous with me and do all the assignments and all the things which are being assigned in a continuous pattern so that consistency is being maintained. And this is what all I need from you. Thank you. Signing off.